Now, is this reaction exothermic or endothermic, Jesse?
Endothermic?
Endothermic. So endothermic means you have to put heat in. Okay. To get the reaction going, you're going to have to add heat. Yeah. Okay. Oh, it shouldn't be. If I've got 91, I should have 2. Now, it's endothermic, it means you have to add heat. Usually, but not always, we write the delta H of the reaction as a separate little dealio off on the side. So here's my reaction, and I write my delta H of R off on the side. You can put the energy as part of the reaction, like another ingredient. So I could, instead of writing it separately like this, I could put the 91 right here. As part of the reaction. I'm going to add 91 kilojoules of energy to cobalt carbonate, and this is what I will get. Okay? If it's an endothermic reaction, you are adding heat. So you would put it on the left side, because you have to add it. If it was an endothermic reaction, this is where it gets kind of confusing. If it's an endothermic reaction, then it would be on the right side.
What do you mean, exo?
I'm sorry, exo, sorry. If it's an exothermic reaction, then the number would be on the other side, but it's written as a positive number when you put it in part of the equation. Because what you're saying is, I'm destroying this, but I'm producing this, this, and this. So I'm producing the energy. I'm producing the carbonate. I'm producing the cobalt oxide. So you never, when you're putting the energy as part of the equation, it's never negative. And so if you saw the number on the right side, you'd say it's an exothermic reaction because I'm producing heat. If you see the number on the left side, then you'd say, oh, it's endothermic because I have to add heat. Okay? That's just something you'll see sometimes in different textbooks. Now yesterday we wrote this equation on the board. And the delta H of this reaction was, I think, 852. This is an endo or exothermic reaction of Mr. Borelli.
Exothermic?
Exothermic, because the number's on the right. The delta H of the reaction is actually a negative 852. This reaction is very exothermic. It's going to give off a lot of heat. So much heat that it will melt the iron and turn it into liquid iron. Now I poured this out yesterday and I said, hey, there's my reaction. And you guys are like, okay, that's lame. Believe it or not, this reaction is occurring right now. Just because it's exothermic doesn't tell us how fast the reaction goes. So it's reacting, it's just reacting really, really slowly. If we come back in 1,000,000 years, all of the aluminum oxide will have, all of the iron oxide will have been turned into aluminum oxide. But we can't wait 1,000,000 years. So we have to speed up the reaction, and there are 2 ways you can speed up a reaction. 1, add a catalyst, or 2, add heat. Okay? We are going to do both. We're going to add both a catalyst and heat, and we're really going to speed this reaction up. But we're going to have to do it outside. So I will lock the door, and we are going to then go